Awesome. Well, hello and welcome to the next episode of 3D30 Trick or Heat Treat. This is our 13th episode. Believe it or not, we did not plan it. I don't think you can plan that kind of awesomeness. And also right before Halloween, obviously. If you're new to 3D30, 3D30 is Velo3D's LinkedIn Live and YouTube Live channel. We host this every 2 weeks. So, feel free to join us as we dive into new topics around 3D printing or additive manufacturing. If you want to know the schedule, we don't announce it ahead of time. You have to follow us on LinkedIn to get the latest show schedule. We announce these about 2 weeks out. In general, we talk a lot about high performance parts. That's where Velo3D shines. That's where we do most of our business. And in that market for high performance metal parts, heat treatments are often critical to achieving the right material properties. But how do we make this process as painless as possible? And how can we go about establishing new standards to follow? Many of the historical standards for heat treatments were developed by large aerospace companies over many years and at significant expense. But now we have additive manufacturing. We have a new way to make parts. And in order to take advantage of that, we might need some new standards. But AM is not the only technology that is evolving. Heat treatment technologies are also evolving and changing. And while we can make new parts and achieve better geometries, we can also reach target material properties that we couldn't reach before. So how do we get companies to actually use that new technology? And that's the topic for today's 3D30 Trick or Heat Treat, the scary truth about heat treatment innovation. And the more you know about something, the less scary it is. So let's get you up to speed. Joining me today is Phil Harris, Marketing Manager, and Derek Denlinger, Lead Metallurgical Engineer at Paulo. So bring you guys in here.
Hey, Mike, sorry, we're having some technical difficulties where the stream is not starting on LinkedIn. So
okay,
give us 1 moment to work those out.
It's not the 13th episode for nothing. You can't put that much out there without having something happen. All right. Well, how are you guys doing today while we get any of these technical issues fixed up? Phil, any new information, any new news?
No new news for me. I think Derek's the one with the exciting day today.
Yeah. Derek, something exciting happened that you want to share?
Yeah. So about 11 hours ago, we welcomed my daughter into the world, out into the world. So a father second time around, just a little while ago. So it's been a big day.
Congratulations. I hear you're not running on a lot of sleep, so we will forgive you for any nodding off that you do.
Thank you. I'll try not to.
Cool. So Amir, just checking in. Do a thumbs up to go forward?
We do not yet. No, sorry.
Okay.
Still working out the kinks. I'm not sure why, but give 2 minutes.
All right. Well, let's do some backgrounds in case anybody is able to follow us. Phil, what's your background? Can you maybe fill us in a little bit?
Sure. Yeah. Thanks for having me on today, Mike. So Phil Harris, I'm the marketing manager and marketing department of 1 at Paulo. So I've been with the company for 6 years and wear a lot of hats, but heat treat is a big part of my everyday, and specifically for AM and HIP, I was involved in the project that kind of got us into that business. So this one's close to my heart. Awesome.
Derek, same question to you.
Yeah. So I'm a lead metallurgical engineer here at Paulo. We've got a team of metallurgists on staff, and so I've been with the company 6 years. And like Phil, and also like Phil, I was involved with the HIP process from the inception of the concept to getting into purchasing and trialing out and developing some of the cycles we do for it.
Awesome. And Phil, a little bit, what does Paulo do? Can you give us a bit of a background in the company?
Yeah, absolutely. So Paulo's 4th generation family-owned company. Been in business for 78 years, and we do all varieties of heat treatment. We do brazing, we do some plating, and then we also just recently got into the HIP business. So we serve a bunch of customers all over the United States and the world. We're the largest privately held commercial heat treater, in fact. And we work in a lot of different industries, for everything from automotive and aerospace to power generation, firearms, oil and gas, defense, the whole gamut. So if it's been heat treated, we've probably touched it at some point.
Awesome. And like, what kind of metals do you specialize in?
Yeah, so a bunch of different kinds again, hitting all those different industries, but a lot of different types of steel, and then specialty alloys like nickel-based super alloys, specifically for things like hot section turbine blades.
Cool. Very cool section. And so, Derek, kind of back to you as the technical expert here. Why do we heat treat? Why take this additional step? What is a designer trying to do?
Yeah. So for those who aren't familiar, heat treatment exists as an after you've made the part sort of a process most often. And so it's usually easier to make a component in by traditionally casting or wrought. In this case, we're talking about additively manufactured. And then afterwards, it's typical that that's not the end properties that you want. And so by utilizing temperature, time, and generally other variables, you can then alter the properties of those parts after they've been manufactured to then achieve what you're actually after in your design. And so that's why heat treatment has been and will remain a crucial part of the manufacturing process.
And Phil, what does that process look like? If somebody's actually trying to get this done on their part.
Yeah, so finding a commercial heat treater like us, and talking through the process, right? So what are the end goals? What are you going to use the part for? What are you making it out of? What kind of specifications or industry requirements are there around it? And then just the commercial issues. So how much volume? When are you going to drop them off? When do you want them back? Shipping and logistics. But I mean, working with a good partner, that's a conversation you have up front, and then the day-to-day should feel simple. Shipping us parts and getting back good ones.
Very cool. Now, we kind of teased it a little bit in the beginning here that our technology on the 3D printing side is evolving, the technology on heat treat's evolving. So, are you seeing that existing specs are enough, or is there a gap between what customers are demanding and what an existing spec looks like?
Yeah, so it's common actually in the aerospace industry. Everyone always thinks cutting edge, aerospace grade materials, and it is. However, it's also very slow moving. And so a lot of the specifications that are out there have been out there for decades. And so they've usually been established for kind of the bare minimum, bottom line, worst case scenario from different phases of processing. And heat treatment is not exempt from that. So those processes or those specifications around those processes, in some cases, are kind of antiquated, and the specifications are outdated. And so with advancements in sensors and controls on equipment such as vacuum processing, and in this case, we're talking about hot isostatic pressing. There are new capabilities that we as the processor can then leverage and utilize in a quality fashion to achieve something that's beyond just what those old specification minimums are.
And is this common knowledge, or would you have to kind of be an expert like you in order to know that this is available?
Yeah, a lot of people are not aware of what the equipment specifically is capable of unless they have direct experience with it. You can read specifications and you can read a lot of textbooks and get a good idea for a lot of the major hitters of the challenges of going through thermal processing. But until you get experience and get into it, there's a lot of things that you may not know. And so that's where someone like us comes in, where we've been processing thermally processing parts for a long time, and so then we're looking at it with a very unique set of eyes through our experience, and can bring some value to conversations around the best way to process something.
And well, let's dive into that. I mean, we like to see technology evolving and changing. What are these changes?
Yeah, so today we're talking about one of the focus points is additively manufactured Inconel 718. Utilizing a HIP, advanced HIP technology. And so what that allows us to do, that technology allows us to fine tune our process with advanced cooling rates and temperature uniformity in this instance to achieve something that could not have been achieved in equipment from 30, 40 years ago.
And I think we have a chart here. Maybe we'll put this up. If you could walk us through what we're seeing here.
Yeah, so this is a simple outline. It's fairly representative of actual heat up and cool down rates, though it's not an actual chart. But what you see is the blue curve shows two peaks, so two different separate thermal cycles. One is common for Inconel 718 that is hipped, where it is isostatically pressed at that high temperature and pressure, and then it's slow cooled. And that is to consolidate the material and eliminate porosity. And then after that, it's then reheated in usually a separate furnace. A vacuum furnace is typical for processing. And then it's heated up to a little bit lower of a temperature and then quenched to achieve certain properties in that material that you need a good quench for. Beyond this, there's some other aging for this material that's typical. But I wanted to highlight here is you see the orange curve is rather different. So the process is actually combining both of these two effective goals into one cycle. And so there's a little bit of not say trickery, but there's a little bit of unique processing there at the end of the HIP cycle. We like to call it a high pressure heat treatment cycle. But then you see we're actually cooling quickly at the end of that HIP cycle. And this equipment allows us to be able to do this sort of processing. And this is a novel approach, and it's something that we've had success with, which is why we're talking today. So,
what jumps out at me in that, you said it wasn't a chart, in that picture, is that the orange duration is like 50% or more. And I know, Phil, you're kind of on the commercial side. What does this mean to customers, just being able to get parts that quickly?
Yeah, only a metallurgist would say that wasn't a chart. But no, so yeah, like you said, Mike, we're cutting out 6, 8, 9 hours there, which, I mean, that by itself is awesome. But the point that I think is cool is, in most cases, HIP and heat treat are two separate vendors or two separate facilities at the same vendor. And this gives us the opportunity to do that all in one cycle in one furnace and under one roof. So we're cutting out a transportation step, packaging, shipping, logistics, an extra PO. So the time savings there is really much larger than just that 8 hours.
And maybe Derek, back to you. What real world impact are we seeing on the parts because of this new process?
Yeah, so this process we worked, of course, with Velo3D on, and this sort of processing, it doesn't work with every alloy in every situation, but when you find these sorts of cycles, you can take advantage of some property edge that it provides. And so in this case, we were seeking tensile properties, elevated tensile properties, and this enabled us with the Velo3D process on printed parts from a Sapphire system to take it to meet the next level of expectation from a customer request who needed that elevated tensile requirement.
And we're kind of mentioning HIP or hot isostatic press. How long has this technology been around? Is this something that's new, or has it been accessible for a while?
Yeah, HIP has been around for a long time. It originated in the 50s, but commercially has been used on casting since the 70s. And the process is simple in that it uses high temperature and high pressure to effectively squish the part from all directions and eliminate internal porosity. And there's not much internal porosity with additively manufactured parts, but sometimes there is, and it is something that has been proven to provide benefits in many instances. And so the hipping technology itself, from a pressure and thermal standpoint, has been around, but you have actually got some instances where you've got temperature gradients within the hot zone of the same furnace that are decades apart in Fahrenheit from one another, from the top end to the low end. And so the modern HIP systems and the way we can approach processing, it really is more of like a heat treatment furnace rather than just something you can put in with that high pressure and that high temperature.
And I know on the two lines here, the big thing that kind of jumps out is these cooling rates are drastically different. What is that, or do you see some impact from that on the materials? Yes,
and so like I said, some instances works better than others. Inconel 718 has promising results. So being able to cool at that fast rate, it's comparable to how the material is traditionally heat treated in a separate vacuum furnace. But those old HIPs couldn't perform that way and cool and quench at those rates. So now we're able to take the process and consider these alternative methods utilizing that ability, which is becoming more and more well known.
And you mentioned it's more and more well known, but it doesn't sound like everybody's using it. What would stop or enable, let's say, a company to be able to access this?
Yeah, so definitely those old specifications, they're either vague or they have them requirements, or in some instances they might actually have limitations that may not make it obvious for someone on the design level to understand that this is a valid process, but also a better process potentially for their additive and manufactured Inconel 718. So that's where it really needs to be something where conversation needs to be had about advancing those specifications and making it something new. And that's what Velo3D is pushing with, and we've been assisting on this particular project. Is a new specification is in committee right now for approval, and material has been tested and is actually in the approval process through the MNPDS program in order to provide that information to get it out there in a more formal fashion, so that the design engineers can see what properties it provides, utilizing the data, and then specify the specification on their prints, and be able to be aware that it is a valid route that should be considered.
And you mentioned MMPDS, and I kind of wanted to double click on that a little bit. For folks who aren't aware, what is MMPDS and what types of companies would use that, or industries?
Yeah, so the MNPDS is basically a library of data around established processes and material combinations. And so there's a rigorous requirement in order to get there, requiring unique, in this case, unique print builds and unique thermal cycles in order to achieve enough data to be statistically significant enough to establish allowables for design. And it's formally recognized by the DoD, the FAA, and NASA as an authority in design data allowables that engineers can use and lean on. And so it's, like I said, it's a rigorous process, and we're going through right now, or Velo, I should say, is going through right now with this example. But once you're on the other side, it's out there. And so anyone who has access to that library then can take that data and incorporate it into their designs.
So you have the MMPDS. It sounds like organizations like the FAA, DoD, NASA are using it. Is there like a spec that's called out that references this?
Yeah, so Velo3D is working right now on developing a specification that utilizes the Velo print equipment and this process through Paulo, and it's AMS 7038. And so that's, like I said, it's in process right now, but it's starting that conversation with this particular example that I think is a really good pattern. And so it's getting good attention, and we're getting good input and good discussions around it. And as with every specification, it deserves just scrutiny, as everyone involved understands. It takes a lot of work to make it happen. But it's the specification at the end somebody could call out as means to process once they've decided that the allowables fit the requirements of their design.
And you kind of mentioned before, this is statistical in nature. There are multiple samples that get sent. It reminds me of a saying that I've heard some of our engineers talk about, is engineers don't use the average, they use the worst case scenario. So I was wondering, what's the experience been in submitting the data? Is this a wide range, narrow range?
Yeah, so it's definitely a challenge, as I know many from Velo3D can attest to. But my understanding is that the properties are consistent enough to be in line with ROT version of Inconel 718, which is quite an accomplishment. But yeah, to your point, each step of the process, there's a window for variation, and when you can tighten up your quality and your controls and your processing to be able to provide it consistently over and over again. Each line of the way, when you get tight, keep it tight on the powder side, on your material, on the incoming, on the printing and its processing, and then the thermal processing side. Then the tighter you can maintain, and with greater quality you can maintain that all the way through, then the higher you can push your performance expectation at the end with certainty. And so that's what we are seeing with this effort that's being put forth.
So then we have this AMS 7038, I think is what you were mentioning. There's an MMPDS in here. There's design rules. Maybe if you could just kind of walk us through step by step, how would a designer go about actually using this and calling this out?
Yeah, sure. So the way I like to think of it, and it's simply put, and maybe a little bit rudimentary, is there's a catalog. The MMPDS is the catalog. I'm going to browse through and figure out what allowables, work with my design. Maybe I need to do some analysis on that to figure out, to verify that this is what I need. And once you've established that, okay, this is what I want out of the catalog, then you as a designer would then specify the specification that led to those allowables. And so then it can be put on the print and communicated to your thermal processor, in this case, Paulo, and say, hey, we want to process to 7038. And then it's, from there, that's the conversation that we want to have. And, the rest should be history in a good way.
And so now they've got this design, they printed on a Velo 3D printer at one of our contract manufacturers. And maybe Phil, back to you. What's the process look like now? How do they physically go through getting this part heat treated?
Yeah, so like Derek said, it starts with the conversation, and if you've got your spec and you've got everything you want on there, then it can be a pretty quick conversation. And if you're not quite sure, or you want to have a deeper conversation about what you need, that's where people like Derek and our metallurgy team come in and talk to you about what you're designing for and what you're really after. But after that, it's about getting a quote and then shipping parts back and forth, which is something we do every day. So that should be the easy part.
And you mentioned like being able to do this process quicker, being able to do it all under one roof. Is that a differentiator for Paulo as well?
Yeah, absolutely. It's pretty rare in the HIP world to offer vacuum heat treating side by side, and our Cleveland facility has 35 vacuum furnaces under one roof with a HIP. So whether it's the annealing or whether it's solution treating or aging, we can handle it all in one place without the finger pointing between the two providers and eliminating some transportation steps, which these days especially is definitely worth it. So yeah, if you'd like to get in touch with us about HIP, Mike Harper's your guy. He's our director of sales. He also does quoting, so he can get you a number quickly, which I think makes everybody happy. And he's got some technical expertise as well. So I'll leave his contact information in the chat and take it from there.
Awesome. And just as a reminder, I know that we've had some technical glitches, but I do see we have a good audience joining us today. We are running this session live. If you have any questions or if there's anything you are curious about with advanced heat treatment, drop us a note in the comments and we'll get to it live. So just in case anyone is curious, we'd love to hear from you. And let me see. All right. So we've kind of unpacked this a little bit. It sounds like we've gotten to a new process. We've gotten the designers comfortable with it. They've been able to call it out on their drawings. They've printed on a Velo. They've got the part heat treated. You mentioned aviation, though, earlier, and that some industries are a little faster to adopt this than others. Where do you see this going? Who do you see moving quicker in this and adopting this?
Want me to take that one?
Go for it.
Like I said, having participated in some of the committee meetings, we have some great participation on that committee, as many of them are. But you see aerospace OEMs from general aviation, DoD efforts, and even space type efforts. And so one thing that's definitely continued need is for everyone to work together where appropriate and as necessary to have those conversations, because I think now at this point there's a lot of people who are establishing what their print systems are capable of and what's possible, but this sorts of conversations of how can we as an industry take additive the next step. I think Velo has done a fantastic job with this situation of making out 718, of having the conversation and pushing the efforts of, hey, let's do something here that can really maximize how we can have an edge with additive manufacturing. And so this slash sheet is set up with the specification for Velo. And so they've set the bar there. It's high and it's great. And the conversations are good with other companies. But I think we definitely need more activity like this and more more people from the OEMs, leading some of the efforts to make some of these standards, more widespread in other areas. And I think that's really valuable. It's really important, and that's the type of thing that's going to help take additive to the next step, to make it seem less scary all around, because there's a lot of great success that's been proven out, and this is one good example of it.
Yeah, I know, just talking with a lot of different companies, those target industries, right? FAA, NASA, DoD, those are prime examples of where additive contributes that value that they're looking for. And now it sounds like we've kind of opened up a path a little bit, a mutual path for designers to call out specific characteristics to get that improvement in material properties. Yeah, sounds like we've done a lot of exciting stuff. Phil, any kind of closing thoughts on this, or where do you see this going?
Yeah, so I mean, we chose to invest in HIP and get involved in this a few years back because we saw kind of this path forward with additive and are excited about what it has to offer. So continuing to invest our time and energy in this is definitely part of our future, and we're excited to support all the people out there making additive parts that want to not settle for the old specifications and want to go to the next level. So I think my big takeaway would just be talk to your heat treater, and hopefully your heat treater's us. But if it's not, talk to them anyway, because having this upfront communication about what's possible is the only way we're going to get to the next level, which is where we want to be.
Nice. Derek, closing thoughts?
Yeah, I definitely echo the conversation point that Phil said, is have a conversation. So many of the times, we get to a certain point where there's parts have been printed and they're ready to ship, and it's, let's just do the traditional method, and there's no time to consider those things. So if you have a thought, have a need, feel free to reach out to us, and we can talk about, maybe there's something we can do, and maybe it's around HIP, maybe it's not. But I think having those conversations with the different suppliers in the chain of what might happen to the product, heat treatment can have a big influence on the end result. And so you need good powder, good printer, but good heat treatment, and having that conversation early on is key, I think, to getting these sorts of advancements kind of more widespread.
Yeah, I hear this a lot. This common theme: when things are changing, in order to take the most advantage of it that you possibly can, you've got to have conversations. You got to be talking to people and reaching out. So definitely appreciate you joining us today for this session. Really informative. We're going to put some links in the bottom for any of the audience to reach out and continue the conversations. But make sure that you follow these LinkedIn channels. Lots of information coming from Paulo and obviously Bill at 3D. And we'd love to hear from any of you in the audience. Great session today, guys. And we'll let you get back to your Halloween and trick-or-treating.
Thank you.